Hey you guys, okay, so today we're going to be talking about applications of derivatives. And within derivatives, we come across critical points. Now the definition of a critical point is a point on a curve with a gradient of 0. Okay, so critical points will show up throughout majority of derivatives. So first we need to define all of them and show a few examples before we actually start to use them. We say that x equals c is a critical point of the function f of x if f times c exists and either if of the following are true. F of c equals 0 or it doesn't exist. Note that we require f of c to exist in order for x of c to actually be a critical point. This is important and often overlooked. The main point of this section is to work on some examples finding critical points. So let's get started. Example 1. Determine all the critical points for the function. The function we have now is f of x equals 6x to the power of 5 plus 33x to the power of 4 minus 30x to the power of 3 plus 100. Now for the solution. We first need the derivative of the function in order to find the critical points. And so let's get that, and notice that we'll factor as much as possible to make our life easier when we go to find the critical points. Let's start with our original function. As you can see, I factored the derivative, but let's try to make this function more closer to a polynomial. Now our derivative is a polynomial, meaning that it will exist everywhere. Therefore, the only critical points will be those values of x which make the derivative 0, so we must solve. Because this is the factored form of the derivative, it's pretty easy to identify the three critical points. They are x equals negative 5, x equals 0, and x equals 3 over 5. So as we can see, polynomials are fairly simple functions to find critical points. Most of the more interesting functions for finding critical points aren't polynomials, however, so let's take a look to find out more. Oh my god, yes, I forgot. This requires a little bit more effort on our part. Example number 2. G of t equals 3 times the square root of t squared times 2t minus 1. Sorry you can't see the 1, guys. Now it's time to find the solution. To find the derivative, it's probably easiest to do a little simplification before we actually differentiate. Let's multiply the root through the parentheses and simplify as much as possible. This will allow us to avoid using the product rule when taking the derivative. Now we need to differentiate. We will need to be careful with this problem. I will tell you why momentarily. Here's our factored equation, but I see something we can eliminate. Oh yeah, a negative exponent. When faced with a negative exponent, it is often best to eliminate the minus sign as we did above. This really isn't required, but can make our life easier if we do that. Notice as well that eliminating the negative exponent in the second term allows us to correctly identify why t equals 0 is a critical point for the function. Once we move to the second term to the denominator, we can clearly see that the derivative doesn't exist at t equals 0, and so this point will be a critical point. Oh my god, I'm tired. So as you can see, we found one critical point, but now we need to find the derivative that is 0. To help, it's usually best to combine this term, and this term into one rational expression. So getting a common denominator and combining gives us g over t equals 10t minus 2 divided by 3t to the power of 1/3. Don't you love it? Notice that we still have t equals 0 as a critical point. By doing this combining, we should never lose critical points. It's only being used to help us find them. Please excuse my ratchet filming. As we can see, it's now become much easier to quickly determine where the derivative will be 0. So in this case, we see that the numerator will be equal to 0. Now, let's simplify this numerator to see what it is. T equals 1/5, so there are 2 critical points for this function. And the critical points to this function are t equals 0 and t equals 1/5. It's all in the functions. So everyone, I hope you enjoyed that little tutorial on how to find critical functions. It's guaranteed to get you out of any pre-cal problem with the best amount of effort. Hope you enjoyed.